Alright, so this is worksheet 8.4, and we're doing number 2 right now. And what it says is they give you a triangle, they give you a right triangle, and they tell you all three sides, and they ask for the sine, cosine, and tangent of a couple different angles. They call this angle R, this is S, and this is T. So what they want you to do is they want you to find the sine, cosine, and tangent of angle R, and they want you to find the sine, cosine, and tangent of angle S. Well, let's write down our little mnemonic device, our little way that we remember sine, cosine, and tangent. Do you remember what the word was? It's kind of a made-up word. SOHCAHTOA. What's the so? How do you spell the so? S-O-H, and then the ka is C-A-H-A, and then the toa is T-O-A. What does that stand for? S stands for what? Sine is opposite over, right, hypotenuse, even though it's not written over here. Okay, that's how we remember it. Opposite over hypotenuse. What's the C? Cosine is what? Adjacent over hypotenuse. Good. And then the tangent is opposite over adjacent. So it all depends which angle we're talking about, right? I could be talking about angle R, or I could talk about angle S. Now, I will never deal with angle T. All right? I'm never going to say the sine, well, I shouldn't say never. In here, we'll never. Okay, in this class, we'll never say, okay, what's the sine, cosine, and tangent of angle T? I'll never do that for the right angle. Everybody with me on that? As you go on a little further in Algebra 2 and Pre-Calc, if you take a trig class or something like that, you would work with that. But right now, we're only dealing with these other two angles. So I'm going to find 6 things. I'm going to find the sine, cosine, and tangent of this angle. Then I'm going to find the sine, cosine, and tangent of this angle up here, angle S. All right, so let's do angle R first. So let's do the sine of angle R, and then we're going to figure out the cosine of angle R, and then the tangent of angle R. Okay? Once we get done doing that, then what do we find? The sine of S, angle S, and then the cosine of angle S, and then the tangent of angle S. And I just want you to write them as a fraction. Make sure you reduce the fraction, but write it as a fraction. It says in the worksheet to write it as a decimal. I don't want you to write it as a decimal. I want you to write it as a fraction, okay? And a reduced fraction at that. Let's change colors. All right, let's take a look at angle R. Here's angle R right here. And I want to find the sine of angle R. So you come up here. This is going to help you. The sine is the opposite side divided by the hypotenuse. So here's angle R. What side is opposite angle R? What's opposite of this? 10. And what's the hypotenuse? 26. So I write it as 10 over 26. But I don't leave my answer like that, do I? No, I reduce it. What goes into both of these? 2. 2 goes into 10 5 times. 2 goes into 26 13 times. That's right. All right. Everybody with me on that? So that's it. That's the sine of angle R. Thing is, you got to do it 5 more times, don't you? All right, but it's not that hard. But that's the general idea. Yeah, there's really no figuring out. Not a whole lot of math except for reducing the fraction. This is just a skill set, just to get you to know what the sine is, what the cosine is, and what the tangent is. That's basically, it's just practice to do that, David. Okay. All right, let's do the cosine of this. Well, the cosine is the adjacent over the hypotenuse. So which side is adjacent to angle R? 24. And the hypotenuse is 26. So we write 24 over 26, but we reduce it. 2 goes into both of those, what? 12 over 13. That's easy. Right? Again, it's just practice so that you understand the sine, cosine, and tangent. Which one's opposite, adjacent, and hypotenuse, and all that stuff. What about the tangent of angle R? The tangent of angle R is the opposite over the adjacent. So what's opposite this angle? 10. What's adjacent to this angle? 24. So it's 10 over 24. 2 goes into both of those. 5 over 12. And there it is. So there's half of the problem right there. I mean, it's a little lengthy, right? Because there's 6 parts to it. But really, is it that difficult? No, it's not like you have a whole bunch of steps for each one, is it? All you got to do is know which one is opposite, which one's adjacent, which one's hypotenuse, and where to put those, in what order to put them for the sine, cosine, and tangent. Let's do this. Let's do the sine of angle S. Let's change colors here. Let's go blue. What about this angle up top here? I'm going to do the sine, cosine, and tangent of this one. And I want you to see some relationships. After we get done doing this, I want you to see some relationships between the sine of this angle and the cosine of the other angle. All right? or the cosine of angle R and the sine of angle S, and also the tangent of angle R and the tangent of S. There's a relationship that you should be able to see by looking at those. But let's do these first. Let's do the sine of angle S. Sine is opposite over hypotenuse. Opposite over hypotenuse. That's 24 over 26, which reduces to 12 over 13. Again, let's look at the relationship. What do you see, Joe?
So sine S is equal to cosine R?
That's right. The cosine of R is the same thing as the sine of S. So if I take the cosine of this angle, it's going to be the same thing as finding the sine of the other angle. Do you see that? All right, I think that's pretty interesting, and that comes in handy every once in a while. All right, so just kind of keep that in mind. So without even looking which opposite, which is hypotenuse and adjacent and all that stuff, what do you think the cosine of S is equal to over here? The sine of R, exactly. It should be 10 over 26. Let's see if it is. The cosine of S, what's the cosine? It's adjacent over hypotenuse. So adjacent is 10 over the hypotenuse, which is 26. Sure enough, it's the same thing, isn't it?
Yeah.
It reduces to 5 over, 13. Yeah. So look, the cosine of S is the same as the sine of R. Isn't that cool? And then the sine of S is the same as the cosine of R. Now look at this. What do you think the tangent? Now the tangent's not going to be one of these, but watch this. The tangent of this angle is opposite over adjacent. Opposite over adjacent. It's 24 over 10. So basically what did I do? Just flipped it. That's right. Because that comes out to 12 over 5. Alright, so the tangent of this angle is actually the inverse of the tangent of this angle up here, the different angle. Again, that kind of comes in handy after a while if you do a whole bunch of these kind of things. It's just kind of interesting to see. Well, that wasn't so bad, was it? It wasn't too hard. Alright. Yeah, it does get harder. That's why this is the first one, first and second one. Alright, but that's all you had to do. You just had to write it. I didn't ask to solve for those angles, did I? I just asked to find the sine, cosine, and tangent of those angles. Alright. Let me pick another one here. Yeah, let's do 3 through 8. Alright. This is pretty much where we took a long time on this in the other class. And we may have to take a little while on it in here too. I really want you to really pay attention here. Because it gets I don't know. I wouldn't say it gets really difficult, but there are quite a few steps you have to keep straight. Thanks. There are quite a few steps that you got to keep straight on this. Now, if you look at the problem, what's it say? It says use a special right triangle. A special. We've dealt with a couple special right triangles. All right, we'll take a look at it in a second to express each trig ratio as a fraction and as a decimal. Remember what I said? I don't really care that you write it as a decimal. Just write it as a fraction and you'll be fine.
Didn't you tell us how to do it?
I did. I'm showing you now how to do it. Yep, I'm showing you now how to do it. So the question says this. Use the special triangle to find the sine of 30 degrees. Now I'm going to show you one or two things that I'm not going to give you a lot of explanation about. All right. When you get into Algebra 2, you'll be dealing with this thing called a unit circle, and they can do their explanations there. But for right now, this is what we want to do. We want to find out what the sine of 30 is. We want to find out what the sine of 30 is without, right, W-O, do you see that? Without a what? Without a coat. What? Without a calculator. Right. You guys would be terrible at that. What's that one show, that TV show where they flip the letters? Wheel of Fortune? Yeah, Wheel of Fortune, right? I gave you like the first three, and still nobody said. Is it Wheel of Fortune? Yeah, it is, isn't it? Yeah. They spin the wheel, and then that girl, Vanna White.
No, that's not Wheel of Fortune.
Yeah, it is. Yeah, you guess the letters, right? I'll take a vow.
Wheel of Fortune is Bob Barker, and you spin the big wheel.
Nuh-uh, that's not Wheel of Fortune. No, that's Price is Right. That's Price is Right. You got the three people there, right? And you guess the letters. All right. Trust me, it's Wheel of Fortune. Not a big fan of Wheel of Fortune, but I know my game shows. All right, here we go. Shh. All right, enough of that. At least I woke you up a little bit talking about the Wheel of Fortune. All right, if that's what it takes, that's what it takes. All right, so look at this. This is a special triangle. Why is it special? Because I want to find the sine of 30, so guess what one of these angles is going to be here? 30. So let's make that 30 degrees. Now, if this is 30 and that's a right triangle, this has got to be 60 degrees. Alright, now here's the part I was telling you about. What I want to do is I'm going to make the hypotenuse equal to 1. It just makes things a lot easier for us. I'm not going to give you a big explanation of why. Just make the hypotenuse 1. Everybody with me on that? Okay. Now, if I know the hypotenuse, and I know it's a 30, 60, 90 triangle, let's review. The other class, it just seemed like I was speaking a foreign language to them. And we just finished going over this stuff, okay, just a few lessons back. All right, so it shouldn't be a foreign language. This is 30, 60, 90. We know some relationships, don't we? Let's write those down. The easiest one is the hypotenuse. Do you remember what that is? The hypotenuse is what? 2 times the what? What length? The short leg. Nobody remembers this stuff?
And then the other one, like the short circle.
You guys are crushing my spirit. You know that? My spirit is being crushed right now. Because the long side, because I go through this. I really try hard. Do you not think, does it feel like I try hard to get you to learn this stuff? Or does it feel like I'm just going through the motions?
Try hard.
Does it feel like I'm trying hard? Because I am. I really am. I want you to know that. I'm trying hard to get you to learn this stuff. But sometimes I don't think you're trying as hard as I'm trying. Would you have to agree with me on that?
I completely agree.
Okay, thank you. All right, so the long side is what? Give me a number. Square root of 3. Thank you, Elizabeth. Times the short side. Okay, the hypotenuse is twice the short side. The long side is the square root of 3 times the short side. You remember that? Okay, which one's the short side? It's opposite the what? The 30. Opposite the 30. There's several angles here. The short side is opposite the 30. Okay, so this is the short side. This is the long side. So give it to me. It's a half. That's right. It's 0.5 or a half. Would you agree? Because this side right here, the hypotenuse, is twice as big as this. So if this is 1, 1 is twice as big as what? Yeah, why are we saying 0.5? My other class did that all the time. Just a half, right? It's a half. All right, I think it's easier, a half. Now watch. What's the long side then? It's the square root of 3 times the short side. Well, I just found the short side. That was pretty easy to find. So what's the long side going to be? Well, it's 1/2 times what? Times the square root of 3, isn't it? Now watch, I'm going to put that over 1. How do I multiply things? Now, not cross. It's just straight up multiplication. There's no equal sign in between here. What's a regular multiplication problem? What do I do with fractions? Multiply straight across, right?
Yeah.
So what do I get? Square root of 3 over 2. Exactly right. So that's how I'm going to write this. Does that number sound familiar to you when I read off the answers? Yeah. Okay. So there we go. There's my nice triangle. I got all of my sides. Now look, they asked for the sine of 30 degrees. I could just do the one thing, find the sine of 30 degrees. But just to let us know how to do some of these things, let's find, let's go with this green. How is this the long side? Because it's opposite the 60-degree angle. Okay, if it's opposite the 60, that's the long side. If it's opposite the 30, it's the short side. This side right here is always the longest side, isn't it? It's the longest side. Okay, the hypotenuse is always the longest. But this is the longer leg, I should say. I shouldn't say side. I didn't say longest. The longer leg, right, out of the two. You got it? Okay. Everybody with me? So now, let's do this. Remember what we did? Sine, cosine, and tangent of certain angles. Let's do the same thing here. But we have actual numbers in here. Or angles. We know what the actual angle is. So watch. Let's do the sine of 30. Let's do the cosine of 30. And what else? The tangent, right, of 30. Now look, these are numbers that you could actually punch into your calculator. You could put in the sine of 30 in your calculator and get a number. Right? You could do the cosine of 30. You could do the tangent of 30 and get a number. But what I want exact answers. I want fraction answers. I don't want just a decimal, because anybody could come in here and just punch those numbers into a calculator and get a number. Okay, I want to know that you figured out how to get these without a calculator. Everybody got that? So let's do this. The sine of 30. Here's the angle. What's the here? I'll write this down just so we can remember it again. Okay, the sine is opposite over hypotenuse. Very good. So what side's opposite? 1/2. So it's 1/2 over what? 1. Well, what's anything over 1? Itself, right? So what's this equal to? What's 1/2 divided by 1? It's just a half, isn't it? So that's the sine of 30 right there. I just showed you how to find the sine of 30 without using a calculator. Everybody got that? And you may not think it's a big deal right now, but again, I keep referring to Algebra 2 because you get into this a lot more heavy. This is kind of like an introductory course of trig, okay? You get into it a lot more heavy when you take Algebra 2, when you take pre-calc, and a lot of you guys will be doing that. You will be taking some of those classes. So that's going to be a very important number to you. If you ask somebody in pre-calc or even calculus, if you stop them in the hallway and you ask them what the sine of 30 is, they should be able to tell you 1/2. All right, just like that. They might have to sit and think about it for a half a second, but they should be able to tell you what the sine of 30 degrees is just by memorization, basically. All right. Okay. Watch the cosine of 30. The cosine of 30 is adjacent over hypotenuse, so it's the square root of 3 over 2 over the hypotenuse. Well, that over 1 is just what? Square root of 3 over 2. That's the cosine of 30 degrees. It's the square root of 3 over 2. Everybody got that? Now look, if you would have punched that into a calculator, you would have got a decimal. There's no way that you would have been able to tell that that decimal is the square root of 3 over 2. You just wouldn't be able to do that. Now, if you punch this into a calculator, guess what the calculator spits out? What's that? Sine of 30. Look, I told you what the answer is. What do you think the calculator says? Huh? 15? The sine of 30 is 15? What's it say? The sine of 30, what did we just say it was? Come on, think a little bit. It's a half, right. What would the calculator tell you? They won't put 1 over 2. What do they put in the calculator? Thank you. It's 0.5. I thought that was going to be a simple little question. All right? The calculator will say 0.5. Now, the square root of 3 over 2, is there any way that you know what the square root of 3 over 2 is as a decimal? Not really. You could put it into a calculator, though, and get, so it's like 0.867 or 0.87 or something like that, okay, just because I've worked with that a lot and I know. All right, but I don't want a decimal answer for this. I want fractions for this. Michaela, you with me on this? Okay, get your head up. No way I'm going to let you just sit there with your head on the table. All right, so let's do the tangent of 30 now. Thank you very much. Let's do the tangent of 30. What's the tangent? It's the opposite over adjacent. So now watch this. Don't fall asleep. If you're thinking, if you're really trying to follow me, you're not going to fall asleep. Your mind will be working. All right? So let's think. Don't just sit there and let it bounce off of you. I can tell that's happening to some of you guys. All right? My words are coming out. It's hitting you right on the forehead and dropping to the floor. It's exactly what's happening. You internalize this stuff. Think. Your mind should be churning up there, okay? And the wheels are turning. And you got to be thinking. If your wheels are turning, you're not going to be falling asleep. So watch. It's opposite over adjacent. Square root of 3 over 2. Now look at that mess right there. I'm going to do it a little bit bigger just so we can play around with this. This is really, I know it doesn't look like it, but it kind of is elementary math when you first did fractions. Now I asked my other class this, not to put down my other class or anything, but it just astounded me that people didn't know this. Watch. If I had 3 over 5, these numbers have nothing to do with these numbers. I'm just going back in time. Let's go back to, I don't know, when did you do fractions? Like 4th, 5th grade, something like that? Let's say 5th grade, okay? Oops, not times. Watch. Do you remember doing this when you were a kid? Do you remember doing this?
Yeah.
Okay, so what do you do? This is a division problem, isn't it? So you take the first one and you keep it the same, but you never divide fractions. We never really divided fractions. We always turned it into what? Into multiplication. But we multiplied by the reciprocal. Very good. Or the inverse. Either word is fine. I don't care. But you flip it, don't you?
Yeah.
You multiply by the reciprocal or multiply by the inverse. And so what do you do there? So you flip that one. You keep the first one the same and you flip the second one. Okay? Look what happens here. The 5's cancel. What's the answer? 3 over 7. Look, let's apply that same line of thinking to this thing down here. Now, what's this bar right here? That means what? It means division, doesn't it? So it's 1/2 divided by this. So we're going to write it 1/2 times what? 2 over, well, the square root of 3. Do you see that? All I did was take this and flipped it and then multiplied. Everybody see that? Look what happens. The 2's cancel, don't they? So what am I left with then? 1 over the square root of 3. Now look, as far as I'm concerned, for you guys in this class, if you wanted to keep it 1 over the square root of 3, I'd be perfectly fine with that. But we learned something just a little while back. Do you remember doing this? Remember we didn't like the square root in the denominator? Okay, now look, you could circle that and that would be a fine answer. I'd be okay with that. But when you read off answers from the book, or if I read off answers from the worksheet, it's not going to look like this. Do you remember what we do here? Multiply the top and bottom by the square root of 3. Do you remember this? We did it. Okay, look back on it. So what happens? Multiply straight across. That's the square root of 3 over, what's the square root of 3 times square root of 3? It's just plain old 3. It's the square root of 9, right? But what's the square root of 9? It's just plain old 3, isn't it? Okay? So look, all this mess right here basically just boiled down to what? Square root of 3 over 3. And that's the answer right there. So these are the answers that you would see in the back of the book if you were to look them up. If I was to read off the answers from the worksheet, these are the answers that I'm going to read off to you. You're not going to find this in your calculator. You'll find a decimal approximation, but you're not going to find this in a calculator, right? You're not going to find this in a calculator. Now, 1/2, you know in your head that 0.5 is 1/2, don't you? So that's easy to figure out. These other ones, you wouldn't be able to figure it out from the calculator. So this is finding the sine, cosine, and tangent of 30 all without a calculator. And again, you may not think that's a big deal right now, but I think eventually it will be. Okay? Let's just do a 45 real quick. This is already a 45, so I don't have to change it. Let's put it right here. Alright, so what we're going to do is we're going to find the sine, cosine, and tangent of 45 degrees. So if that's a 45 degree angle right here, what's this one up top here going to be? That's going to be a 45 degree angle. Now, what did I say we were going to do? Now, you might not understand why I do this, but what length did I make the hypotenuse? 1. So I'm going to do that again. And really, if you look at it, it kind of made it nice because, look, it was opposite over hypotenuse. So really, this was just the sine, wasn't it? It was adjacent over the hypotenuse. That was the cosine. The tangent was a little trickier because you had to do some division, but it was nice having this to be a 1. Wouldn't you agree? Yeah. So it's not exactly the reason why, just because it makes it easier, but it does make it easier. So look, do you remember the little formula for 45, 45, 90 triangles? The hypotenuse was equal to, do you remember? What number did we use? Square root of 2 times one of the legs. Does it matter which leg? Because what's true about both of the legs? They're both equal to each other, okay? So this right here is the square root of 2 times one of the legs. If I knew this leg, I would multiply it by square root of 2 to get to this. But if I know the hypotenuse, how do I get the leg? I don't multiply, I do what, David? I divide, that's right. I divide by the square root of 2. If you're not sure about that, look, just stick the numbers in. What's the hypotenuse equal to? It's 1. Equals the square root of 2. People are walking on the ceiling, don't worry about that. Times one of the legs. So how do I solve for one of the legs? Divide by the square root of 2. Now watch this. We already did this one time already. 1 over the square root of 2. How can we, square root of 2 over 2? Or sorry, square root of 2 over square root of 2. And what does that give us? Square root of 2 on top. What's on the bottom? Just a 2. So what's the side right here? It's the square root of 2 over 2. What's this side right here? Yeah, without doing any math at all, right? Because the two sides are equal. Now look, what do I want to do? I want to find the sine. Oh, I almost wrote 30. Of what? 45, right? I want to find the sine of 45. And also, I could find out the what? The cosine of 45, and I can also find the tangent of 45. Agreed? Let's do this real quick. The sine of 45. The sine of 45 is the opposite over the hypotenuse. Square root of 2 over 2 over 1, which is just the square root of 2 over 2. That's it. That's the sine of 45 right there. As a fraction, not a decimal. What's the cosine of 45? Well, the cosine is the adjacent over the hypotenuse. Same exact thing, isn't it? Put that to a calculator and see. Find the sine of 45 and then the cosine of 45. They're exactly the same number. It's like 0.71 or something like that. Okay? What about the tangent? Watch this. This is kind of nice. The tangent is the opposite over the adjacent. Look, that's right. Look, it's something over itself. What's anything divided by itself? It's 1. There it is. Punch it in your calculator if you don't believe me. Tangent of 45. and you'll see that it's equal to 1. All right? Those are pretty cool things. That's what they're asking you to do on numbers 3 through 8. Okay? Let me give you a worksheet. No, I'm going to have you hang on to those. Let me give you a worksheet. Thanks. And try to do as many of these as you can, and we're going to do the same kind of thing tomorrow. Okay? We're just going to go over more questions on this thing tomorrow.
Sydney, Berkeley,